Hello future engineers, subscribers, viewers, and students. Here is another video about cables under uniform load. So the cable will be in the parabolic shape. Then I also include the question also determine the maximum sag D sub n. So we have here the hint, locate the point O where the cable is tangent to the pipe. So if we make O the origin, the equation of the cable will be simple. And in the second solution, I'll make A as the origin and the answer, especially for the length of the cable, should be the same. So since the total weight of the pipe, which is carried by the cable alone, is 960 pounds, that means that the distributed load is 960 divided by 80 feet. So that is 12 pounds per foot. That's the uniform load. Then by squared property of parabola, if O is the origin, then you have 20 as to xa square is equal to 7.2 as to this distance square. This distance is 80 feet minus xa, or this is xb. So quantity 80 minus xa square, solving for xa with your calculator, xa is 50 feet. So if xa is 50 feet, then xb is 80 minus 50, 30 feet. Then we have this equation of the cable, y equals wx squared over 2h. You can easily derive that by considering a cable, and we have a point here. The distance is x, the height is y, then summation moment about that point equals 0. So h times y equals w times x over 2. So that's why you're able to derive that formula. So let's just apply it directly for ya 20 feet equals w 12, xa is 50 feet, quantity square over 2h. So h is 750 pounds. Again, to derive 750, you may draw the free body diagram of the portion AO. The tension at O is H. At A, H, and W times XA, we already found XA. Then you sum up moment about O. In general, H times Y, if this is Y in general, is equal to W times X, if this is X in general, times X over 2. So that's why you can easily derive that. So we just apply YA is 20 equals 12, 50, XA is 50 from there, square over 2H, or H is 750. Another way is YB 7.2, you may replace this by 7.2, W is 12, XB is 30, you replace this by 30, so 30 square over 2H, you will get the same results of 750 pounds. The vertical component of force at A is WXA equal to the area of this rectangular load, weight of uniform weight of pipe times XA. So 12 uniform weight of pipe, XA 50, so 600 pounds. From there, we can compute VA, which is 12 times 50, 600. So tension at A therefore is the maximum tension, and it is square root of H square, 750 square, plus V sub A square, 600 square. So the maximum tension which occurs at A is 960.5 pounds. For the equation of the cable, you just apply squared property of parabola. Y as to x square equals 20 as to 50 square. You may also use 7.2 as to 30 square. The result is the same, x square over 125. So y prime, the derivative is 2x over 125. The length of the cable, therefore, is integral from negative 50 to positive 30, negative 50 because the origin is here, and XA is 50 feet to the left, so that's why it's negative 50, and XB is 30 feet to the right, that's why we have positive 30. Square root of 1 plus y prime square, or dy dx square, that's y prime dx. Using your calculator, the length of the cable is 86.03 feet. Now for the maximum sag d sub n, take note this is the origin and the center is 40 feet, so half of 80 feet. So that means the center is 10 feet to the left of the origin. So the slope is equal to 2 times negative the slope at this point. So let us show that the slope at the point on the cable at the center is equal to the slope of the chord AB. Because that's the principle and that's the sense. So 2 times negative 10, because the center is 10 feet to the left of the origin, over 125 from here. So negative 4 over 25. The slope of chord AB is indeed negative because it is directed down to the right. So that's a negative slope, and it is equal to 20 minus 7.2, negative of quantity 20 minus 7.2, all over 80 feet. So it's indeed negative 4 over 25, just like that. So y sub m, therefore, ym is the vertical distance of that point on the cable at the center from the x-axis, which is the axis of the pipe. So we have a small ym there. So into the formula for y, which is x squared over 125, so negative 10 quantity squared over 125, that's 0.8. So if that is 0.8, this one, the vertical distance from the x-axis to that point on the imaginary chord at the center is the average of 20 and 7.2, then minus ym. So d sub m is average this vertical distance from the x-axis to the point on the point directly above at the center to the imaginary chord is 20 plus 7.2 divided by 2. That's the average. Then we subtract that ym there 0.8, and you will get the sub m of 12.8 feet. Another way, because the tangent at the point of the cable at the center is same as the slope of this imaginary chord. So from the tangent here to this vertical line, the vertical distance is slope, which is negative 4 over 25 times distance, which is 40 feet, because this is the center. So therefore d sub m is 20 minus slope 4 over 25 times 40, then what, minus ym. So 20 minus this intercepted vertical distance. So 20 minus this intercepted vertical distance, which is slope of the chord. This is the slope at the point on the cable at the center. So 4 over 25 times 40, because from the center to A is 40 feet. Then we subtract further ym, which is 0.8. So that's why it's also 12.8. Another way is from the derived formula and from the general cable theorem, that the product of the horizontal component of force times distance from the point of the cable to the chord, imaginary chord, is equal to the moment at the same point on the cable. So this is maximum, because the maximum moment at the point on the beam loaded with uniform load is at the center, which is WL square over 8 is the maximum moment. Therefore, D sub M is also maximum. So this is H times D sub M by the principle on the general cable theorem is equal to the moment at the same point on the beam loaded with uniform load, which is WL square over 8, which I demonstrated in the previous video, and you should know that. So D sub M is 12.8 feet. So I presented 3 ways to do that. This is the 4th way. If the origin is at A, then the equation of the cable in general is the same as the general quadratic equation ax squared plus bx plus c. But when x is 0, y is 0, so that's why c is 0. The equation of the cable with A as the origin reduces to that. So y prime derivative is 2ax plus b, and y prime at A is negative because the slope is down to the right, and that negative slope is vertical, negative of vertical component wxa or v sub a, negative of 600 divided by h, which is 750. So y prime at A is negative 4/5, and it is equal to B because y prime at the origin at A is negative 4/5 equals to A times 0 plus B. So that's why B is negative 4/5 because this is 0 when x is 0. So this is the vertical component of tension at B, which is W times XB, and XB is 80 minus XA or 80 minus 50, 30 feet. So 12 pounds per foot times 30 is 360 pounds. The slope at B is positive because it is up to the right, and the vertical, it is equal to the vertical component of force divided by H. So 360 vertical component of force divided by 750, 12 over 25. So y prime at B, or the slope of the tangent at B, is 12 over 25. So substitute into this formula here. 12 over 25 equals 2ax, and x at B is 80, then plus B, which is negative 4/5. So A is 1 over 125. So the equation of the cable, therefore, with A as the origin is ax squared plus bx, or 1 over 125 x squared plus b, which is negative 4/5 times x. Derivative, therefore, is 2x over 125 minus 4/5. So the length of the cable AB with A as the origin is integral from 0 to 80 this time, because this is the origin, of square root of 1 plus y prime. Y prime is 2x over 125 minus 4/5 or minus 0.8 quantity squared dx. So using your calculator, the length of the cable is 86.03 feet, just like that. Then finally, another way of computing D sub n is equal to this vertical distance, which is negative, and that is slope of AB, which is negative 4 over 25 times 40. Then the vertical distance of the point at the point on the cable at the center is defined by this equation of the cable, which is negative quantity 40 square, because at the center x is 40, over 125 into this equation, plus b, which is negative 0.8 times x, which is 40. In other words, the point at the center on the cable is equal to negative of this quantity. But we make it positive, so that becomes positive distance of this point to the imaginary x-axis or horizontal line through A is that value. Then we subtract the distance from the x-axis through A to the imaginary chord at the center, which is this, and that is negative 4 over 25 times 40, then plus that value, which is treated positive, you will get the same answer of 12.8 feet. So that's it for this video.